Hello, Honors Algebra students. Mr. Lawrence here. I know it's been a long time since you've heard from me, but I'm back. And we're going to go ahead and review what we've been doing in the class past few days. Remember that Wednesday you're having a quest, bigger than a quiz, smaller than a test. All right, we're going to review simplifying rational expressions. And first thing I'm going to do is I'm going to look to factor, and I see the numerator is going to factor. So I'm going to factor that numerator, t. Let's see here. I need two factors of 24 and subtract to get 2. Oh, sounds like a 6 and a 4 to me. And I want a positive 2, so the 6 has got to be positive and the 4 is negative. And my denominator is t minus 4. Before I go ahead and simplify, I'm going to note that t cannot equal 4. Because if t is 4, then my denominator turns to 0. Now that I know that, I can simplify, crossing out the numbers that are both 4 less than t, and my answer will be t plus 6 when t does not equal 4. Pretty simple stuff. I know you guys are good at it. I won't belabor that point. All right, this green one here looks like I didn't give myself a whole lot of room to work. Hold on one second. Okay, there we go. I got a little room to work with. Remember, I'm going to factor first. And there's 4 terms in the numerator. That's a factor by grouping problem. So I think I'm going to group this pair with this pair. Always being sure to grab the sign. And let me see here. I'm thinking 4 is going into both of them, and a 4x squared actually. And let's see, is that going to be 14? Yeah, 14x plus 8. Ooh, I didn't get the GCF. I only got a common factor. Notice that? Yeah, there's actually an 8 that's going to go into both. I'm surprised I didn't catch that, but that's okay. Caught it now. So I'm going to pull out an 8x squared from both, and that'll give me a 7x plus a 4. I like that for a couple of reasons. One, I'm grouping, and 2, look at my denominator. Okay, now here, I think I'm going to pull out a negative. And I'm thinking 9. So I'm going to pull out a 9. And that's going to give me a 7x, a negative 9 actually. It's going to be a 7x plus a 4. And there we go. That's all over 7x plus 4. I'm not ready to cancel yet. I'm going to go ahead and do the last step of the grouping. And so I'll get 7x to the 7x plus 4 times 8x squared minus 9. And that'll all be over 7x plus 4. Now I'm getting ready to simplify, but first I'm going to note my restriction. And it looks to me that 7x plus 4 would be 0 when 7x was the same as negative 4, and therefore x was the same as negative 4 sevenths. So I know that my restriction, when I'm done simplifying, will be that x cannot equal negative 4 sevenths. So I'm going to cancel out those, and I'm left with 8x squared minus 9 when x does not equal negative 4 sevenths. Okay, now let's get on to some operations. Remember, the first thing I'm going to do, factor. So I'm going to change this guy right here into an a plus 3, a minus 3. Gonna have to factor this guy. Looks like I'm going to need 2 factors of 18 that are going to subtract to get negative 17. Well, looks like I might have it right off the bat. 1 minus 18 ought to do it. So I'm going to rewrite that denominator as a grouping problem. And so it'll look like, let's see here, I'm going to have to do 6a squared minus 18a plus a minus 3. So I'm going to group this, group that. I'm going to pull a GCF out of here, 6a I believe, and I'll get a minus 3 plus an a minus 3. I'm going to pull the a minus 3 out, and that'll be times 6a plus a 1. So my denominator, my new fraction is going to look like this. It's going to be, here I'm going to go to a new page, a plus 2 over a plus 3, a minus 3, and then I'm going to have to, uh, sorry, lost my place, going to have to subtract 2a, so I'm going to have minus a 2a, and then I'm going to have an a minus 3 over a 6a plus 1, right? Okay, so now that I actually want to subtract it, let me move that subtraction sign. I'm going to go looking for my LCD. And I know I'm going to get an a plus 3 in my LCD. And that'll take care of that guy. And then I need a quantity of a minus 3, and that'll take care of this guy and this guy. And then I'm going to need a 6a plus 1. Take care of that guy. I'm going to multiply each part of this, each fraction by the LCD, or by what the LCD is missing. So I'm going to multiply this guy by the 6a plus 1 in both the numerator and the denominator. Okay, and over here I'm going to be multiplying by a plus 3 in the numerator and denominator. All right, so let's go ahead and do that. This is a FOIL problem in the numerator. The denominator is just going to be 6a plus 1 times a plus 3 times a minus 3, all in quantities, of course. That'll be the same over here, 6a plus 1, a plus 3, a minus 3. So I'm going to FOIL this and get a 6a squared plus a plus 12 plus 13a plus 2. And then here I'm going to distribute a negative 2a. So I'm going to put minus 2a squared minus 6a. And notice I changed the sign to a positive because I distributed the negative. I went like this. And then I distributed. Okay. Now I'm going to combine like terms because my denominators match. And I'm going to get 4a squareds plus 7a plus 2. And that'll all be over 6a plus 1, a plus 3, and a minus 3. Okay, now I didn't go find my restrictions, but I still can. This is all true when a does not equal 3, negative 3, nor negative 1/6. And there we go. That technically should be a part of my answers. All right, very good. So let's see here. So I got that one. Okay, this one here, same type of problem. Gonna move it up a little bit, give myself some room to work. And okay, on all these problems, the first thing I did was factor. Well, I'm going to factor my numerator and my denominator of the second fractions. I'm going to get 1 over 2x minus 5, and that's going to be plus 4 times the quantity of x plus 2 over 4 times the quantity of 2x minus 5. Hey, look at that. I can simplify this. The 4's can cancel. And now look at that. I have the LCD already. I simplified the fraction, one of the fractions first, and I ended up with my LCD. So I'm cool. All I have to do is combine my numerators. I have an x plus 2 plus 1. That would be x plus 3 over 2x minus 5. Look to do that. All right, solving rational for x with a rational expression. This one's a little bit different. We're still going to factor first, and we're going to look for an LCD, but we're not actually going to make all the fractions have the denominator. We're going to multiply by the LCD to make our fractions disappear. So the first thing I need to do is factor this. So I need 2 factors of 4 that add to get 5. Well, I'm going to have w's there. Looks like 4 and 1 make 5. And there's a plus in the back. It's my Wendy's double stack. Bam, bam. So now most of you can tell me that the LCD for this problem is the quantity of w minus 4 times the quantity of w minus 1. And you're absolutely right. And let's see here. I don't want to move that whole thing. So I'm going to go ahead and just clone this. And I'll rewrite in there. This is my LCD. What is that? Oh, not a 4CD, Mr. Lawrence, an LCD. Sorry about that, guys. Okay. So I'm going to take this first fraction. I'm going to rewrite it a little more neatly. And it's 3w over w minus 4 and w minus 1. And then I'm going to take 2 times w minus 4 plus 3 times w minus 1. Okay. And I'm going to multiply this fraction by it, this fraction by it, and the first fraction by it. Now remember, I'm not trying to make the denominators the same. I'm trying to get rid of all my denominators. And because I can multiply all 3 terms, it's not changing the whole equation. I'm changing all 3 terms by the same amount. So I have the same equation. It'll just look a little bit different. Well, what happens in this first fraction? These cancel, those cancel, and I'm left with a plain old 3w. The second fraction, these cancel, and I have 2 times w minus 1. On the third one, the w minus 1s will cancel, and I'll have 3 times the quantity of w minus 4. Well, I'll distribute 2w minus 2 plus 3w minus 12. I'll combine like terms. 3w equals 5w minus 14. I don't like having all my w's on both sides, so I will get rid of the 5 w's, giving me negative 2w equals negative 14, and then I will divide by negative 2, and w will equal 7. Okay, now I have to go back and look for my restrictions, make sure this doesn't violate any of the restrictions, and it looks like my restrictions are w cannot equal 1 or 4. And so since w is 7, I know that my answer is valid. If I had gotten a 1 or a 4, I would throw it away. All right, one more just like that. Rational expression. Go looking for my LCD. All right, I know my LCD is going to have on r plus 1. I know it's going to have an r minus 1, right? Now, I didn't have to factor anything in this problem. So, to get rid of all my fractions, I'm going to multiply this term, this one, and this first fraction all by the LCD. So, in this first one, the r plus 1 and the r plus 1 will cancel, leaving me an r minus 1 times an r minus 1. Here, the r minus 1 and r minus 1 will cancel, leaving me with a negative 2r times the quantity of r plus 1. And over here, nothing will cancel, but I do have a negative 1 times an r plus 1 and an r minus 1. All right, I'm going to FOIL this and get r squared minus 2r plus 1. I'm going to distribute here and get negative 2r squared minus 2r. And going to FOIL and then distribute a negative. Well, this FOILs as r squared minus 1 and then I will distribute the negative. So I'm going to get a negative r squared plus 1. All right, going to combine some like terms here. I see the r squared, so I'm going to have a negative r squared. I've got minus 2r, minus 2r, it's going to be minus 4r plus 1 equals negative r squared plus 1. All right, I'm going to add r squared to both sides. And when I do that, I'm left with a negative 4r plus 1, and that'll equal 1. Well, now I can go ahead and subtract 1. Negative 4r is going to equal 0. Divide by negative 4, divide by negative 4. R is going to equal 0. I'm going to go back and check my restrictions. Looks like my restrictions are that r cannot equal plus or minus 1. So r equals 0 is okay. And there we go. I'm all done. All right, you're going to get some practice with this on Monday, problems 5 and 6. Please come in for help sometime if you're not sure before Wednesday. Mr. Lawrence signing off. Good night, everybody.